Hi there, this is Mrs. Molina, and today I'm going to be giving you some information in regards to energy in our ecosystems, and we're going to do that through looking at food chains and food webs. So you're going to need your Arctic food web handout. You'll need 4 different colored markers, and you will need your notebook. So let's go ahead and get started with our Arctic food web foldable. The first thing you are going to want to do is to cut out windows, kind of like we did with the virus foldable replication foldable. You're going to cut along each of these lines right here so that when you fold this back, it makes a window. So the easiest way to do that, I think, is to fold or make a crease along the bottom edge of your picture, and then just cut that carefully. The smaller the cut you make, the less gap there'll be, but it doesn't really matter if there's a gap. Okay, so I'm going to go ahead and cut that one, and cut this one. Doesn't have to be perfect, as mine will not be. Okay, so that gives you a slit now, right there, that you can stick your scissors in so that you can cut up to the top so that it makes a flap. And then you'll also cut this one up to the top, like so. And that also will create another flap. Now, the other thing you'll want to do so that this will fit in your notebook, or at least I need to do this because I have one of the smaller composition books. So I'm actually going to go ahead and cut this off on the edge. And I'm going to cut off this top part here along that dotted line, and that way it's going to fit a little bit better into my notebook. Alright, so you'll want to pause the video here, and you are just going to keep on folding along these bottom edges. You'll have to make a separate fold here, cutting, and then cutting up the lines to make all your flaps. So if you want to pause the video and take care of that, do that now. Alright, once you have all your flaps cut out, okay, which you really don't need to cut the sun. I should have told you that before you pause the video, but that's okay. We're going to go ahead and glue this down. In your notebook, it should be on page 40. And what I'm going to do is take my notebook and turn it sideways. And I'm going to place the top part with the sun and the polar bear. It's going to need to overlap into my other page just a little bit. So I'm going to actually glue it down kind of in the crease and on my paper here, being careful not to put glue on any of those flaps. So let me take just a second to glue this down, and then we'll move forward with the explanation of food chains and food webs. Meaning to go back and add some more glue later so that sticks in better. In fact, I think I'm going to go ahead and put another line of glue along there. All right. Still not wanting to stick very well. Let's see. Again, helpful glue. Hence, if you put it on the paper, both papers, it does help it to stick. All right. Now, what this represents is an Arctic food web, and we are going to start by making some food chains. So pick any color that you like, and the main source of all energy on our planet, hopefully you already understand, comes from the sun. So we want to look here at all these different organisms. We've got the Arctic hare, the Arctic wolf, polar bear, walrus, krill, ringed seal, Arctic cod, phytoplankton, and purple saxifrage, at which ones are producers, which ones get their energy directly from the sun. And if you look down here, there's 2 organisms that can do that. The phytoplankton, which you would find in the ocean, at the surface of the oceans, and they are going to photosynthesize, as well as obviously our plants or flowers here. All right, so let's start with our phytoplankton. What eats the phytoplankton? Well, there's many things on this page that do, but we're going to start with the krill. So the krill eat the phytoplankton, but I'm not going to draw an arrow. When I do a food chain, I don't draw the arrow in the direction of what eats what. I draw it in the direction of how the energy flows. So I'm going to draw an arrow from the phytoplankton to the krill, indicating that the phytoplankton provide energy to the krill. Okay? Then the Arctic cod is going to eat the krill for energy. So the krill is then going to provide energy to the Arctic cod. Okay? What eats the Arctic cod? Well, the ringed seal does. So the Arctic cod provides energy to the ringed seal, which then provides energy to the polar bear. So there's just one example of a food chain. Again, remembering that the arrows show the direction that the energy travels. All right, let's look at another food chain that's similar. We're going to start again with our phytoplankton, okay, which provide energy to the krill. Okay, but this time the walrus eats the krill, so we're going to show the arrow. The krill provides energy to the walrus, which then, believe it or not, provides energy to the polar bears. Sometimes polar bears will attack and eat the walrus. All right, next up, let's do another one. This one's also going to start with our phytoplankton, which we understand that the krill are going to eat. And we're going to continue like we did before. I kind of made a little big my other arrows. Okay, but the krill are going to be eaten by the Arctic cod. Okay, but this time the walrus eats the Arctic cod. So the Arctic cod provides energy to the walrus, who then we understand can provide energy to the polar bear. All right, let's do one more food chain on this side, and then we'll look at these organisms over here. Okay, so we're going to start with the phytoplankton again, providing energy to the krill. Okay, the krill provide energy to the Arctic cod. But this time, and we're going to skip the ringed seal because polar bears, will sometimes directly eat the Arctic cod. They don't have to necessarily eat the ringed seal first. They can skip over the Arctic cod. All right. And you know what? I should have told you to get 5 markers because we need to do one more on the other side. So grab one more marker just so you can have a different color to show a different food chain. All right, this one we're going to start over here with our flowers. And what do you think might eat those flowers? Hopefully you guessed the Arctic hare. So the flowers provide energy, well, the plant, I should say, provide energy to the Arctic hare, which then provides energy to the Arctic wolf. Okay, just one food chain represented there, but as you can see, they're all connected in one big food web. Okay? Now, let's go back, and there's some other terms we need to understand within a food chain, and that is what level are these organisms feeding at? Okay, and you would hear things like primary consumer, secondary consumer, tertiary consumer, or you might have the beginnings, which would be your producers or your autotrophs. So let's identify those quickly. Pick any color of marker that you like. You can use a different color. You can use the same color you've been using for one of the food chains. It doesn't really matter. All right, let me move this up just a little bit and zoom in a little bit so you can see what I'm writing. All right, so we already mentioned when we started this that our phytoplankton, oops, I accidentally glued that down. Okay, phytoplankton are going to be serving as our producers because they're going to use the sun's energy directly. Okay. our flowers are as well. We could also use, remember that other term, autotroph, which means they automatically get their energy from the sun. They make their own food. All right? All right, anything that is getting energy from a producer in the next level is going to be considered what we call a primary consumer. So because the krill is getting energy from the phytoplankton, we are going to call him a primary consumer. Okay, well over here, the Arctic hare ate the purple saxifrage, so he is also a primary consumer. Okay. All right, well, the organisms that eat the primary consumers then become the secondary consumers. So anything that's eating the krill, like the Arctic cod, we're going to consider them that's an E, secondary consumer. Okay, and we also have the walrus that's also eating the krill. So in this food chain, the green arrow, he is functioning as a secondary consumer. But as we'll see in just a moment, okay, in fact, I'm going to go back and kind of underline this in the green because he's also functioning at a different level in a different food chain. If we follow the phytoplankton, which is eaten by the krill, which is eaten by the Arctic cod, which is then eaten by the walrus, well, that then in this food chain would put him as what we call a tertiary consumer. That's a third level. Okay, and I'm going to highlight that or underline that in pink so that we understand that in that food chain, that's where he functions. All right, so if we keep moving along, go back to this food chain. Okay, so this is our producer, primary consumer, secondary consumer. So that makes the ring seal our tertiary consumer, or third level. Okay, I'm going to put that's third, if you can't read my handwriting. Okay. And so then above third, we would say quaternary feeding level, but at that point, we usually just say the fourth feeding level. All right, so we've got them all labeled except our Arctic wolf. So let's go back and see where he fits. We started with our plant down here as our producer. Then we have our Arctic hare. Let me move this down so you can see, is our primary consumer. So that would make, in this food chain, the Arctic wolf a secondary consumer. And I didn't spell that right, excuse me. So that is how we look at this food chain and food webs. If you have any questions, be sure to ask, or you're also welcome to look up anything. It's a pretty simple concept on the internet. All right, now very quickly, I want to move over here, okay, and we're going to title this page Ecological Pyramids. And we're not going to take long notes over this. You should already have those in the little booklet that I gave you where you watched the videos and took notes, okay? But I do want to look at a few examples of ecological pyramids that you might see on the STAR test. Okay, so let's start off with just a basic pyramid. Okay, and we're going to call this our energy pyramid. This is looking specifically at energy. All right, if you'll give me just 1 second. All right, we can put different levels. Let's just do 4 different levels. So I'm going to draw a line here, here, and here. All right, and our bottom level are going to be our producers. I'm going to use some different colors here. All right, and let's say the producers have 10,000 kcals of energy. That's KCAL. That's what I wrote there in case you can't see. All right, our next level up, let's have something that eats these producers. Let's say we have insects. They're going to have 1,000 kcal of energy available to them. And something that might eat those insects would be mice, which are going to have 100 kcals. And then what might eat the mouse? Maybe a snake. Who's going to have 10 kcals. Kcals is just a unit of energy. Okay? But something we want to point out in this is, if you notice, every time we move up a level, we have less energy available to that level. In fact, every time I move up a level from here to here, okay, 90% of the energy is used. Okay, so that only leaves 10% of the energy. Y'all see that? 10% of the energy that these original producers got from the sun, only 10% of it is left to provide energy to the insects. Okay, so again, when I move up this way, of that 10% that the insects got, 90% of it gets lost due to the insects doing what they have to do, living, breathing, all the things that they do, as well as they give off heat energy. So there's only 10% left to give to the mice. And same thing, once again, 90% of the energy that the mice had is lost, and they only get 10% available to use. Okay, so as we move up the energy pyramid, well, let's say energy decreases. The amount of energy available decreases. Okay. Another type of pyramid that you might see is what we call a biomass. And this is basically how much stuff or how much mass does a certain group of organisms take up. Okay, this time we're just going to break it into 3 just for the sake of example. So let's say we have grains down here. Well, grains relative to everything, let's say there's about 8,000 grams of grain. Okay, well, in order to support, that's how much grain it would take to support about 300 grams worth of chickens. Okay, and that's how much it would take to support about 80 grams of human. Okay, so that's called biomass, how much mass there is. And again, you can see there's less mass at the top than that there is at the bottom, because it's going to take more energy, just what we talked about, to be able to support the organisms at the top. So there can't be as many of them in order to sustain them. All right, one other pyramid that you might see that's a little bit different. Doesn't really deal with energy. Okay, it has to do with a concept called biomagnification. And basically this has to do more with contaminants, things that might get into the water. I'm going to go ahead and break this one down into 5 levels. The number of levels doesn't matter. 1, 2, 3, 4, 5. Okay. We know down here that we have our producers. Okay. And so if a producer eats an organism, this is going to be our secondary consumers. The amount of contamination that they get is going to increase as we move up. Let's say tertiary, let's see, 4th, 5th level. So I'm going to show you a video that explains this better than I'm explaining it to you right now. But basically, as we move up this pyramid, the amount of toxin concentration, I'm going to abbreviate that, increases. So let me take just a second to move over and let you watch just a short video that hopefully will help explain this concept.
Certain toxic substances, like the pesticide DDT, accumulate in the tissues of animals. This is called bioaccumulation. When DDT is sprayed on a marsh, its concentration in the water is very low. DDT is picked up by the plankton living in the marsh, and it accumulates in their tissues. Small fish that eat the plankton get a higher dose of DDT because of the accumulation resulting from eating many plankton during their lifespan. Larger fish that eat many smaller fish receive an even higher dose of DDT. Birds that eat fish, such as this heron, will receive a still higher dose because they eat many fish throughout their lives. This increased concentration of toxic substances in the bodies of animals higher on the food chain is called biological magnification or amplification. From the lowest trophic level, the plankton, to the highest trophic level, the birds, the concentration of DDT in body tissues may increase by a factor of over 100,000. As a result, the populations of several predatory bird species have drastically declined.
Okay, that's all I have for you. If you have any questions about food chains, food webs, or ecological pyramids, be sure and ask. Thank you.